All right, let's just jump right in. We tend to think of our money, our stocks, our credit card swipes, the entire global economy as something that happens right here on Earth. But what if I told you its heartbeat, the very pulse that keeps everything in perfect sync, is actually ticking thousands of miles above our heads in the dead quiet of space? That's the hidden connection we're going to unpack today.
So let's start with a puzzle. You've got a high-frequency trader in New York making a billion-dollar trade, and at the exact same moment, there's a GPS satellite just screaming through its orbit. They seem like they're in two totally different worlds, right? But believe it or not, there's a direct, absolutely critical link between them, and it's got nothing to do with finding your way to the stock exchange. It's something way more fundamental.
To really get this, you have to wrap your head around the insane speed of modern finance. I mean, we are talking about an industry that processes almost 1 billion messages per second. 1 billion! Just let that sink in. Every single one of those messages, every single trade has to be put in the right order perfectly. If that sequence gets jumbled, you get chaos. So how on earth do you organize that kind of speed?
Well, the answer is time. And here's the kicker. The most important thing that GPS satellites give the financial world isn't location, it's timing. They are, for all practical purposes, the ultimate source of truth, an ultra-precise, globally synchronized clock that says exactly who bought what and when down to the nanosecond.
What that really means is that the GPS system has become something extraordinary. It's the world's invisible universal clock. It's a massive piece of critical infrastructure that most of us just use for driving directions, without ever realizing that its real job is to be the planet's timekeeper.
So the official term for what these satellites provide is P&T services. That stands for positioning, navigation, and timing. Now, we all know the P and the N. That's what gets you to a new restaurant. But it's the T, the timing. That's the real unsung hero here. It's the invisible signal that makes sure the entire global economy, not to mention power grids and cell networks, are all marching to the exact same beat.
And this dependency, it runs deep. It's not just about giving high-frequency trading algorithms an edge. We're talking about global regulations, like Europe's super strict MiFID II, that actually legally require all trades to be timestamped with this crazy level of accuracy. It creates a completely secure, bulletproof audit trail. So if anything goes wrong, regulators can go back and see exactly what happened and when. It's the very foundation of trust in our financial system.
But here's the problem, and it's a big one. We've built our entire modern financial world on this incredibly sophisticated system that is, well, also alarmingly fragile. This invisible clock we all depend on, it has a single point of failure, and you better believe our adversaries know it.
And hey, don't just take my word for it. This quote is from Dr. Brad Parkinson, the guy who is literally known as the father of GPS. He himself has warned that our total reliance on this one system represents a single point of failure for much of America. I mean, when the chief architect of the whole thing sounds the alarm, it's pretty serious.
So how could someone actually attack this system? Well, the two biggest threats come from right here on the ground. First, there's jamming. That's basically the brute force method. You just blast out a bunch of radio noise to completely drown out the faint GPS signal coming from space. But then there's spoofing, which is way more sneaky. That's where an attacker broadcasts a fake, counterfeit GPS signal that's actually stronger than the real one, tricking receivers into thinking it's a different time or a different place.
And when you actually analyze these attacks, you start to see a clear pattern of weak points. A full quarter of them are made possible by weak or even non-existent encryption. Another 20% come from vulnerabilities in the high-frequency uplinks, and another 12% are because of weird anomalies in the command and control path. So we're not talking about random bad luck here. These are systemic, built-in weak points in the system.
And this is not just some theoretical threat, it has happened. Back in 2014, Russia's entire version of GPS, a system called GLONASS, went completely dark for 11 hours. It was a massive wake-up call that these global satellite systems can, and do, fail. Now, can you just imagine an 11-hour outage of our GPS? The economic damage would be absolutely catastrophic.
So all of this brings us to the crucial next question. What do we do about it? Well, recognizing just how fragile this system is, experts and governments all over the world are now in a race to build a plan B. The goal isn't to get rid of GPS, but to make damn sure it's not our only option.
So what are the leading alternatives out there? Well, you have GPS, which we know is space-based and has that super weak signal. Then there's a system called ELOREN, which is ground-based and uses powerful radio towers. And finally, you have something that sounds like it's straight out of science fiction, CRONES, a system that uses cosmic rays to navigate.
The cool thing is each one has a totally different strength and, more importantly, a totally different way of failing. And that's exactly what you want in a backup.
Let's zoom in on eLORAN for a second. It's basically a souped-up modern version of an old radio navigation system. Its key advantage is just raw power. The signal is broadcast from huge towers on the ground, and it is 1.3 million times stronger than GPS. It's so powerful that it's incredibly hard to jam, and it can even work indoors.
And then we've got the Cosmic Rain Navigation System, or CRONS. Now this is truly next-level stuff. Here's how it works. Particles from deep space are constantly slamming into our atmosphere, creating these showers of secondary particles called muons. If you set up a dense network of sensors on the ground, an AI can actually detect these muons, calculate the path of the shower, and use that as a fixed reference point to figure out a precise position. And since muons can go right through rock, this system could work deep underground where GPS could never dream of going.
So when we look to the future, this isn't about picking one winner to replace GPS. It's about weaving all these different technologies together to create a system that's more robust, more resilient, and a whole lot harder to break.
This is the vision right here. It's called a multi-level resiliency model. The best way to think about it is like a safety net, but one with multiple different layers. If one of those layers breaks, there's always another one there to catch you. It's a strategy of defense in depth, but for our entire sense of time and location.
And here's how those layers break down. At the very top, you have your global space-based systems. That's GPS and its counterparts. Right below that, you've got a continental layer, which is where a powerful system like eLORAN would live. Below that, you've got local systems, and at the very bottom, you have totally autonomous systems, like inertial navigation, that don't need any external signals at all. Each layer is there to back up the one above it. So this is really the key takeaway from all of this. The goal is not to replace GPS. GPS is amazing at what it does. The goal is to build a much richer, more diverse ecosystem of PNT services around it, so that our reliance on that one single system is never again a single point of failure. At the end of the day, resilience comes from diversity.
And that leaves us with one final big thought. We've just seen how the entire global economy is essentially propped up by an invisible clock in space that's way more fragile than any of us imagined. It kind of makes you wonder, what other invisible, critical systems are we all taking for granted every single day?